We're here with Moshe Sahler, director of the QuantumBiofuels AlgaeFuel project at the East Hampton Laboratory. And Moshe is going to be explaining a little bit about the process that we're working on to produce gasoline alternate from algae. So Moshe, let's start with you explaining the overview of our project.
All right, so what I wanted to present here is we have here basically what I call feedstocks of our selected algae that we're going to use as the base for our gasoline alternate production. What basically we have here are just simply 3 tanks that are simulating the natural environment that they normally grow from, which is a highly saline, semi-tropical type climate. And our goal basically upon cultivating the algae is to extract it, isolate it, and then basically with like a high pressure hydrogenation, sort of simulating petroleum-like cracking to come up with a renewable and recyclable gasoline alternate resource that could be produced basically artificially in the laboratory. That basically is an overview of what we're doing.
Can you comment on how we've progressed up till now with the project and where we need to go from here?
Well, we have, I feel, succeeded in reaching what I call a feedstock stage in which we can probably now, with even just what we have here, replicate as much as, depending upon as many basically cultivating containers as possible, we could basically replicate the feedstock here. And at this point, though, we do need additional input, though, for more capital-intensive equipment to proceed further. Right now, it's just a very preliminary stage, basically displaying what we have accomplished with limited resources, but displaying we do have capability. But in order to proceed, we are looking for collaborators or input, obviously, to help this very worthwhile venture.
So essentially, QuantumBiofuels Phase 1, we've proven that the algae can be cultivated in this indoor environment.
That's right. Basically, what you basically are seeing here with these lights these are metal halide lamps that are intended to simulate outdoor sunlight, and these are commonly used in aquaculture and hydroponic usages. And as we can see, basically, as you see the olive green-like color of the algae itself here, that we have come to that point that we started basically from several small tubes of algae culture, and now have succeeded in transplanting them now to actually several tanks.
So then this we can call like preliminary Phase 1.
Correct.
So Phase 1 further development would be to perfect and gather data on the most efficient way of cultivation.
Right.
And then perhaps come up with designs for large scale, the scaling up of the cultivation.
Absolutely. And we are at that point that we need now to perfect the isolation, pre-concentration, and most effective way to get a scale up and an isolation, obviously, process down pat before we can go on, obviously, to further equipment and scale up.
So Phase 2 would be then to start working on the design of a system for extraction and for creating the gasoline alternate, and even perhaps even testing that alternate on a small scale.
That's all part of our overall Phase 2 package. And That's, I mean, and in addition, I would add to that is we do need the equipment, though, in place as well
For research.
for further research.
Phase 2 research.
Development and phase 2 development.
In general, so far, are you pleased with the way the project is developing?
I personally am ecstatic and very pleased with how things have gone so far. I actually did not envision even this quickly how, the possibilities of where now we have come. We started basically, this was a bare room, what you see here, but with bits and pieces, nuts and bolts, and a very limited shoestring budget. I think what we've created is at least a physical entity that demonstrates, that entrepreneurial skill and innovation are alive and well, even in our times, especially with alternate energy.
Thanks, Moshe.
It was a pleasure.